So let's look at this week. I am very happy to be back, guys. I was in the hospital for a week. I had COVID at the end of August. I still had COVID when I got put in the hospital a week and a half ago. The symptoms never got away. I'm still testing positive. They said I could test positive for 6 months. It doesn't mean it's contagious or necessarily even active, but I have a lowered immune system due to the leukemia that I fought. And so they said you could test positive for 6 months, but I was still having symptoms, 101-degree fevers for the whole month of October. And they said, it's time to put you in the hospital and do something about it. So I had IVs hooked up in both arms for a week. And they gave me 5 days of COVID IV drugs, which apparently you can't get by pill, and a bunch of antibiotics, a bunch of fluids, and all kinds of good stuff. And finally got me back feeling good again. So I'm excited. I forgot what it's like to feel good. So it's always good to get back to that point where you actually have some strength and confidence that you're going to make it through the day. So, all right, I'm going to put up what we're looking. We're in the quadratics unit here. We've looked at solving quadratics with the grouping method. Thank you, Cadence. We looked at a couple of methods. Today, we're going to just talk about solving quadratics by factoring. We've looked at a few methods of factoring, taking the greatest common factor out. That's always the first thing we want to do for factoring quadratics. Yeah, things. So I've got these notes that are posted in your Google Classroom, and I'm going to put them up on the screen, and we're going to work through some of them together. So at the top of these notes, it tells you right off the steps that you need to look at. Solving quadratics by factoring. Number one, move all the terms to one side and set the equation equal to 0. Set it equal to 0. If we're going to factor this. If we're going to find the zeros of the equation, that's when it equals 0. So we need the equation equal 0. And then we factor it when possible. The greatest common factor, or pulling out the difference of two squares. We looked at that method. By factoring by grouping, however we factor it, and then we check it back, multiply them back together, see if you get back where you started. Set each factor equal to 0 and solve for each x value. So we'll look at that, and then write your answer as x equals this and x equals that. And those would be the places when you graph it, because we also looked at solving by graphing. This would be where it crosses the x-axis. X equals -2, x equals 1, whatever it turns out to be. Remember, if you end up with imaginary answers, this could be x equals -3i and +3i. Right? It might not be something that crosses the x-axis on a graph if your answers end up imaginary answers, because we know there's going to be two answers for every quadratic equation. Right? We know that because the rules tell us if it's x squared is the largest exponent, the fundamental theorem of algebra says there are two solutions. Whatever the largest exponent is, there are that many solutions. If you're just looking at a linear equation, if this was just -24 minus 24 equals 0, the largest exponent's a 1. There's only one solution to that, right? X squared, there's two solutions. So let's do a few of these, solving each equation by factoring. Okay, it's already been moved to one side. It's already equal to 0. So step one's already done. So factor. So looking at x squared plus 9x, first thing we need to check, is there a greatest common factor? Well, there is. Each term contains an x. And if I factored that out, x squared divided by x is x. 9x divided by x is 9. So there are the factors. X times x plus 9 equals 0. This can't be factored any farther. That's as small as it can get. So now we set each factor equal to 0 and solve for each x value. And that goes back to the simple reason is, if we have two things we're multiplying together, which we do, we have two things multiplying together, and the product, the answer is 0, one of these has to be 0. There's no way you can multiply two things together and get 0 unless one of the things you're multiplying is a 0. So the answer could be, well, this one's real easy, maybe just x equals 0. So it could be that x equals 0, and that's why it all equals 0. If not this one, it could be, or x plus 9 equals 0, because we set this factor equal to 0. Solve it, which means solve it for x. Subtract 9 from both sides. So either x equals 0 or x equals negative 9. In either one of those cases, this will equal 0. If we want to check that, this one's easy to check. 0 plus 0 equals 0. But this one, negative 9, so negative 9 squared plus 9 times negative 9 almost looks like a G. I don't like that negative 9. Let us make him a little cleaner. So negative 9 squared plus 9 times negative 9 equals 0. Just taking this negative 9 and substituting it everywhere there's an x. Negative 9 times negative 9. That's how you square that. That would be 81. All right, because negative times a negative is a positive. Positive 9 times negative 9 is a negative 81. 81 minus 81 equals 0. So it checks out. So either one of those solutions could be making that true, either whether x equals 0 or x equals negative 9. So that's how we write our answers as. Now we can do it, I guess, and would be even more appropriate because either one of those, they're both a solution. They're both a 0 for the equation. All right. Let's try another one. 4x squared minus 8x equals 0. Well, again, let's look for a greatest common factor. Since it's already been set equal to 0, we skip that step. But I see there's a 4 in each term that we can divide out, and there's an x in each term. So we can divide out 4x. So when we divide 4x out of 4x squared, that leaves us an x. We divide 4x out of negative 8x, that just leaves negative 2. We can always multiply that back together if we're going to double check. 4x times x is 4x squared. 4x times negative 2 is negative 8x. So that would combine back to be the same thing. So now that we've got the factors, they're in their simplest form. So let's set each one equal to 0. So either 4x equals 0 or x minus 2 equals 0. So in this one, we divide both sides by 4. So x would equal 0 is one of our answers. And our other answer is when we add 2 to both sides. X equals 2. There are our two solutions. X equals 0 and x equals 2. Those are both solutions for this quadratic equation. All right, let's look at factoring the next one because this one's a little different. Both of these. Let's skip this one. Let's go to this one. We're not going to do all these. I don't want to take up the whole class period just working all these. Leave some of them for you to practice on your own. When I see this right away, I go, wait a minute, 9x squared. That could be a perfect square because 3x times 3x is 9x squared. So this could be a square. 25 is a square because that's 5 times 5. It's a difference of two squares. Difference is when we subtract. So we can use our shortcut factors like this. 9x squared is 3x times 3x. We know what the square root of that is. The square root of 25 is 5. So one of them is positive, one of them is negative. We was able to use our shortcut because this is the difference of two squares. If you're practicing these other problems, this is also the difference of two squares. X squared and 4 are both squares, and it's taking the difference between them. So you can use that same method over here. So now we need to find out what the solutions are. We haven't solved it yet. We factored it. We haven't solved it. So either 3x plus 5 could equal 0, or 3x minus 5 equals 0. So this is our two solutions. We need to solve these for x. Going to subtract 5. On this one, we're going to add 5. So over here, we got 3x equals negative 5. Over here, we got 3x equals 5. We're almost there. So 3x going to divide by 3, both of them. So this one, the answer is x equals negative 5/3. So if we graph that, we would see it cross the x-axis at negative 1 2/3, or negative 5/3, just short of negative 2. This one divide both sides by 3. And the other one is 5/3. So we see on both sides of the y-axis an x equals negative 5/3 or 5/3. Both of those are the solutions. All right. Let's move down to these. These look a little different. First, let's look at this. X squared minus 10x plus 21. Okay, this is just a simple quadratic. We got x squared as our first factor. So it's just a coefficient of 1. So we can ignore that. We just need to know the factors of 21. So we need to know two numbers that would multiply to be 21 and add to be negative 10. Two numbers that multiply to be 21, add to be negative 10. See, this is add, this is multiply. Well, 21 doesn't have that many numbers that can multiply to be 21. Cadence has already jumped on at top 7 and 3. But for it to equal negative 10, it needs to be negative 7 and negative 3. All right, negative 7 and negative 3 will also equal 21. So that means this factors into x minus 7 and x minus 3 equals 0. All right, so that's the factors. The solution is when we set those equal to 0. X minus 3 equals 0. Add 7, add 3 to both sides. Okay, so x equals 7 or x equals 3. That's our solutions. Okay, let's do, let's see, let's do this one. This one, first thing we want to look at is I got a 2, a 2, and a 24. That means I can factor out a 2, which means x squared minus x minus 12 times 2 equals 0. Now we factor what's inside here. Again, a coefficient of 1, so we need numbers that multiply to be 12, or negative 12. Multiply to be negative 12 and add up to be negative 1. Multiply to be negative 12, add up to be negative 1. It's all right, Cora, glad you're here. So 12 can be 1 and 12, 2 and 6, 3 and 4, and that's about it. 4 and 3 is the same as 3 and 4. We need it to add up to negative 1, and we need it to multiply to be a negative 12. So that means one of these would be negative. So in this case, it's got to be 3 and negative 4, because that would multiply together to be negative 12, and they would add together to be negative 1. So 2 times x plus 3 times x minus 4 equals 0. So now we set all these equal to 0. 2 equals 0. That's not true, so we throw it out. X plus 3 equals 0. Subtract 3 from both sides. So x equals negative 3. And x minus 4 equals 0. Add 4, x equals 4. So this solution we throw out because 2 does not equal 0. Our two solutions are x equals negative 3, x equals 4. All right, let me see what else we got on here. More practice problems. All right, more practice problems. It's all practice using the form, the methods that we've looked at up to now, grouping, factoring, with the greatest common factor taken out, the difference of two squares. We haven't got to the quadratic equation yet. Don't worry, we'll get to it. We'll get to it. We got one other left. This says identify the roots of the quadratic equation. This one's already factored for you, so all you have to do is set that equal to 0 to find what the roots are. So x plus 5 equals 0. X plus 6 equals 0. So x equals negative 5. X equals negative 6. There's the roots. These others are the same thing. It's just factoring. Factoring there, factoring there. There's where we set that equals 0. You're going to end up tossing that one out, right? Because negative 2 does not equal 0. Let's look back at these other practice problems, see anything else different. Find the solutions to each. Find the solutions to each. Let's do one factor by grouping. Now, let's do one at the bottom of the page down here. One of the factor by groupings. All right, so we have a coefficient of 3 and coefficient of 30. Now, look at greatest common factor. That 13 does not have any factors. It's just 1 and 13 is the only thing factors of 13. So we're not going to be able to pull a greatest common factor out of there. It is already simplified, as simple as it gets, unfortunately. So let's multiply 3 times 30. Well, negative 30, but still, we're looking at the factors of 90, right? And there's quite a few factors of 90. But we need one to be positive, one to be negative, and we need the negative to be larger. But we're going to do this by grouping. So we're going to figure out how to get this negative 13. So, of course, 1 and 90, 2 and 45, 3 and 30. Will 4 go into 90? No, 4 will not go into 90. 5 and 18. 6 go into 90. Yes, it will. 6 and 15. 7, no. 8, no. 9. 9 times 10. We don't have to go any bigger because the next bigger ones will start going up this side and we'll get the same numbers. All right, so if this is going to be negative 90, then the bigger one is going to be negative because this has to be negative 13. So when we look at that list, which two can we add together? Oh, look, 5 and negative 18. 5 and negative 18. So we're going to split this into a positive 5x and a negative 18x. Now here's where it gets to be the key. Okay, so 3x squared, and then we're going to put one of them with that one. And then we're going to put one of them with the negative 30. If we want to further be able to factor this down, 5, if I put the 5 with, let me just do that. Put the 5 with the 3, I'm stuck. I can't go any further. So let me try, since that's not going to work, let's put the 18 first. Negative 18x. And then here we'll put the 5x over here on this side. So now 3 and 18, I can pull a factor out of that. 5 and negative 30, I can pull a factor out of that. You try to put the numbers where they both work. If I switch them 18 and 30, I can pull out a greatest common factor. I can pull out a greatest common factor, but I couldn't with the 3 and the 5. So I'll put it that way. All right, so let's see what we can factor out. Greatest common factor, just these two terms here. Well, they both have a 3 because you can take 3 out of 18, and they both have an x. So 3x, and when we factor that out, that leaves x minus 6. Okay, so when I factor out 5x minus 30, well, I can't pull an x out because only one of them has an x, but I can pull 5 out. 5. Oh, let me put the 5 outside the parentheses because I'm factoring it out. It's a plus 5. Right, it was a positive 5. X, and when I take 5 out of negative 30, that leaves negative 6. Okay, so I've got two terms now. I've got 3x times x minus 6 plus 5 times x minus 6. I can factor out a greatest common factor. They both have x minus 6. So when I factor it out of that, I get 3x. When I factor it out of that, I get 5. Now I've got it down as simple as it gets. And I can solve it. It's either x minus 6 equals 0 or 3x plus 5 equals 0. So this would be when x equals 6. And this would be x equals negative 5/3. All right, that is factoring by grouping. This is factoring by difference of squares. This is factoring where the leading coefficient is greater than 1. This is factoring where it's just a 1. And this is using greatest common factor, pulling out of there. So there's different methods all right there on the front page. And then there's extra. You can print these out or write them on paper. There's extra problems of this to practice. Let me go over here real quick. Just to show you, page 2 gets a little tricky because they're not equal to 0. They're not equal to 0. So we probably should look at one of those. Let's look at number 11. That looks kind of tricky. So we got to put all the terms where they're equal. So I would subtract x squared and add 1 to both sides. So over here, negative 2x squared minus x squared. Now we just have 1x squared. And then we got negative 50 plus 1 minus 49. And these should all cancel each other out. X squared minus x squared, negative 1 plus 1. Now I have set it equal to 0 first. Now I can factor it. X squared and 49 are both squares. And it's a difference of squares. So we can use our cheat method. Just say x times x is x squared. 7 times 7 is 49. One of them has to be a positive, one has to be a negative. So x plus 7 equals 0, which means x equals negative 7. Or x minus 7 equals 0, which means x equals positive 7. All right, so this page has some where you got to rearrange them a little bit to get them equal to 0. But you just move everything to one side. Whichever way you want to move it. You can move it whichever way you want. You know, if you look at some of it and you're like, well, I'll move them all this way. Well, maybe it's easier. Maybe it's easier. So, all right. That is what we're doing this week. We are practicing our factoring. Let me show you. Here's our assignment in Go Formative. You have 4 problems. It says solve the following quadratic equations by factoring. All right, so he's factoring. We're not to the quadratic equation yet. We'll get there. So don't do this by quadratic equation just yet. We're learning how to do it by factoring. And so 4 problems, click on there, show your work. I repeat each of the problems on there so that way you do have the problem on that page also. You can use the pencil, you can use the typing tool, however you want to do that, just show all your work. 4 problems. That's it. That's simple. Not going to throw a whole lot of shit, going to throw 4 factoring problems. And then next week, after Thanksgiving, because next week you get the week off, guys. So get your work done early in the week and make your Thanksgiving break as long as possible, right? If you're behind, try to get things caught up by Friday so you can enjoy that whole break for Thanksgiving. Want that whole Thanksgiving break. So do what you need to do to get caught up. If you need help, I will be here on Wednesday and on Friday. And even if it snows, I'll probably log on. That's not going to affect us in virtual school. Our buses run on ice. We don't have a problem in virtual school, right? So we can still get to class. All right. If you got questions, certainly you can hang around. Otherwise, I'll let you go. Enjoy your Thanksgiving if you don't need to be here Wednesday or Friday.